do some construction, interpret histogram. What a histogram? Histogram actually is like bar chart. They are very similar. Okay. Later on, they will tell you what's the difference between. It's just like this, you know. These are bar chart or histogram. Bar chart is histogram. Depend on what they represent. Okay. Okay. Depend. The representation is different between histogram and bar chart. But these are just they look the same. It looks like that. So how you group data, they will test you on what does it represent, how many data are there, and so on. Yeah. Understand the purpose and uses of different forms of statistical representation. You need to know what are they used for, and you draw some inferences from the diagram I'm going to give to you. They'll ask you a question in the exam. How many people are this? How many people are that? How many people don't go to work? How many people are not working? How many male? How many female? That kind of thing. Yeah. So this is what we call data representation. Or like Manjula just mentioned, data handling. Okay, collection of data. Data is a set of results compiled by either you do observation. You know, people observe lah. Okay, when they observe, they count. So after observing, they need to count. Okay, and then either you observe, either you count, or you do interview lah. Interview is actually it can be one-to-one, face-to-face. You can do telephone. You know, do you like to use this shampoo? Oh, how many people say yes? How many people say no? So these are the things that you do. You collect all these data and then you represent. After collecting data, that's why these people will draw out a diagram now to show to the whole world how many people like this Pantene shampoo, how many people like Dove shampoo, and so on. Okay, so or Head and Shoulder, yeah. So these are the data that they collect and then put it up on the result using representation. Either to bar chart, pie chart, line chart, depends on what they want to show you lah. Okay. Okay, when collecting data, we use the tally method to record data in an organized manner. Just in case they begin with this. Okay, when I collect data, you know, if I want to do counting, sometimes it's very difficult to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So if they use a piece of paper, they will probably ask you a question. Do you like laksa? Yes. People, yes. No, they don't answer. They won't put a line. So if they ask, you like laksa, then they put another line. Oh, you like laksa? Yes. As long as you have a 5, 1, 2, 3, 4, 5, easier to count this way because you consider one group, is it? This is called grouping, okay? It's very difficult to say 1, 2, 3, and then one group is a 4. Very difficult. So they try to make it easy. Some people use 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is considered one group. So if I count, this is considered 10, and then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, another 10. So this is considered 10, this is considered 20, you know. So actually, how many are there? Okay, there are two groups. One group is 10, two groups, 2 times 10, 20, you know. So that's how they compute data by using tallying method, okay? This is called tallying method, and they make use of the line to count. Like in this case, you look at the first one, okay, like the first one, laksa, how many are there? So you count now, the first one is a 10, right? So if I have 10, 10, 20 plus 2, 12, that's how easy to count. So every group, the moment I see a line, is considered one group already. So I know one group is 5, okay? So you have two groups, I have 10, that's how we count, yeah? So in the end, you add up lah. Total, I have how many people that you have interviewed students that like this kind of food. Total is 35, you know, you add up together, yeah? So this is how they tally, using the method of tallying method. Yeah, this is called tallying method, using line to count, yeah?
Mr. Wong?
Yeah.
Does it mean that how many students are taking the laksa, how many students are taking the fried bean? Is it?
Oh yeah, that's right. How many people are taking laksa? How many people
taking fried? Okay.
Upon collection of data, we can use after you have the data, how are you going to show to people how many people like laksa, how many people like fried bihun, curry chicken, and so on? How do you show people? So if you show this kind of a diagram to the audience, people might not see very clearly, you know, 12, 10, 8, 5, 35, you can't really see properly. So you need diagram to draw representation, and that's where your representation comes in. Your pictorial diagram, either use pictorial diagram to represent something, either use the bar chart, graph chart, pie chart, or histogram, or even line chart. Okay, so depending on what kind of data that you want to show to the audience, you use different kind of representation to show to them. We shall start with a pictogram. Okay, pictogram. Pictogram comes from the word picture. So you are using picture to represent. Okay, picture is not so intimidating. A picture, you have a picture to represent something, so it's not so intimidating. Some people like pictogram because it's very easy to understand. Okay, but the problem is when the data get very complicated, you cannot use pictogram. So pictogram is a graph chart that use picture. Sometimes you use picture, sometimes you use symbol. Now, as I explained to you, please take note. I remember there was one question in the exam. They actually give the data to the student, and they ask the student what kind of representation is best to represent this kind of data. Okay, so good that you take note of all these things. Take note. Okay, all right. What is it for? What is a pictogram for? So a pictogram is a graph. How do they use? They use picture, symbol. Symbol are like signs like that. Symbols are signs. It can be a kind of signs. Okay, or to represent data. It might not be a picture. It can be just sign of a. It can be anything. A symbol can be like that. This can be a symbol. Okay, this can be a symbol. They can use any kind of symbol. They can use a symbol of exclamation mark. So they can use a symbol to represent something. Yeah. Why do they use a pictogram? Because it's very easy to understand, to translate data to the audience. So people like to use this, but when the data, like I said, when the data get too complicated, it's not a very good idea to use pictogram. Okay, this is one example of a pictogram. Recall that in the earlier, we have recorded data for favorite food of students, right? So now using this data, we're going to draw a pictogram to represent the same information. So instead of using like that, when I give you like that, sometimes using a telling method very difficult to see, isn't it, right? You look at this, it's very difficult to see. Or maybe you look at a number, also very difficult to see. But if you use like that, now you know how many people like laksa, how many people like bee hoon, curry chicken, and so on. Because you look by the number of lines, isn't it, right? You can see that the line, they are actually in line. So the line is the same. Okay, so up to here, the least people who like to eat is fishball, isn't it, right? Because they have the least number of symbol. This is the key, this is the key, keyhole like that, isn't it, right? Or it can be a person, he's a skeleton person. So you just take away the two hands and the two legs. You have to. Sure I understand. Oh, it's my watch. Okay, now you look at it. Then how many people like? How many like the kind of food the most? By looking at the symbol, you know that people like laksa the most, isn't it? By the number of symbol that it represent. Okay, so if I give you the kind of symbol, one symbol can represent anything. One symbol can represent one, right? One can represent one. So it depends on me. I say, okay, one symbol represent one. If one represent one, then you count how many of that? You have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, isn't that right? So if I say one symbol represent one, then how many people like laksa? 12 lah. But they can actually change, because when the people get too many, you don't expect them to draw too many symbols, right? So they'll take one symbol represent 10. Okay, let's say one symbol equals to 10. Well, 10, then you got to count like that. You have a 1, 2, 3, 4, altogether there are 12, right? 12 times 10, that means you have 120 people like laksa. So you must see the representation. One of these doesn't really represent one. Unless they tell you, they tell you, represent 2, then you have 12 times 2, 24. So one of the symbol can represent anything. Okay, so you could be very careful when you're looking at symbol. You got to look for the number of people that the symbol represent. So from here, let's say if I say, okay, one symbol represents 5. Let's say I change. Okay, I say one represent 5. One symbol represents 5. Then can you tell me how many people like curry chicken?
Eight times 5.
Answer?
Curry chicken 8%.
Huh?
40.
40 correct. Because 8 times 5
Yeah.
Because one represent 5, right? If I have 8 of them, then means 8 times 5 then they'll give you 40. So you must see what is the representation of the symbol. For every pictogram, there must be a key. Okay, the key will show you. This is important here. The key will show you how many units each picture represents. So this is an important part they try to tell you. How many units each picture represent? Okay, all right, not necessarily one. For large quantity of data, it will be more convenient to use a picture to represent more than one unit. That's why I was mentioning just now. So when you get too many, it's very difficult to draw symbol. Can you imagine? I need to draw 120 symbol. I draw 120. Let's say I one represent one. If there are 120 people, last time I draw 120. Not possible, isn't it? Right? So I'll take one symbol equal to one symbol represent 10, then you know that if you have 12, then you times 12, then you have 120. So it depends on how many representation that I will tell you. Okay, in the exam they will tell you all these things, so you must look out for it. Some example. The number of hours for students. So this is the hour This is the represent the hour. Okay, training for the tennis tournament represented in the pictogram. For spend using how many number of hours spent training for tennis tournament. So you can see one alarm clock represents 5. So how many hours this guy spend? John, how many hours John spent?
20
hours. Right? Because you 4 times 5, right? Then Sandy 1, 2, 3.
It's 30. 6 times 5. 30.
6 times 5, right? Then Vincent
42.5.
8.5 times 5.
I think this one is a half. Don't
Half.
Okay, again, notice there's a half. Okay, so this is 2.5, right? 2.5 times 5 give you what? 2.5 times 5 give you anybody?
2.5
times 5 give you 5, 25, 12.5. So 12.5 hours. Yeah, so that's how you do. Yeah. So this is half. There's a half here also. Okay. Maybe you tell me what is this also
8.
What? 8.5. So you have 8.5 times 5 and then they have
42.5.
42.5. Okay.
8 times 5
is it 8.5 times 5? 5 times 5, 25. 5 then 40, 42.5. Yeah. Okay. Yeah. So that's how they represent. They give you a pictogram to make you count. You have this in kind of exam, very simple. You notice this kind of thing is very simple, right? It's very easy to do. Yeah. All right, this is the answer. I'll just move on. So if I ask you in the end, what is the total number of hours spent? Total number of hours spent. You add them all together. You add this plus this plus this plus this. You get the total hours. Yeah. Okay.
Yeah.
Mr. Wong?
Yep.
So just add them all together to get the hours, right?
Yeah, right. Just add them all up together because they ask in the end. Finally, they say the question. What is the total number of hours they spend training together? So if this guy John spent 20, this guy spent 30, 42.5 and 12.5 and so on. What is the total number of hours they spend? Just add them all together. So this is how. Just like that. No, nothing really. Yeah. Just addition only. Is it okay? Okay, so this is a pictogram. Yeah. So you notice pictogram very easy to understand, isn't it? Right? But the only thing about pictogram is you must know how many they represent. You must know how many they represent. I think in the exam they like to give you pictogram. Yeah. Okay, that's pictogram. Now move on to the next one. We have a bar chart. Now, there are two kinds of bar. There's a horizontal bar chart and a vertical bar chart. Vertical bar chart look like that. Yeah. Horizontal bar chart look like that. So I can't really ask you which one do you like. They depend on which one, how you want to use. Okay. So maybe we look at the kind of foot of measurement again. A horizontal bar chart where the bars lie horizontally across the scale. Horizontal bar chart you can see is from the left to right, whereas vertical bar chart is from bottom to top or top to bottom, depending on how you see it. Now you notice behind the background, I want you to notice something. Okay, maybe we start from the Lhasa. We know that Lhasa got 12, right? 12. Lhasa got 12. I'm going to put down 12 here, okay? All right. In the exam, it's good that you put a number outside, so you know that this one represents 12, rather than you always look to the bottom. Very difficult to see, isn't it? Sometimes it's good that you write on the paper what is the number that is representing the bar. So this is 12 out. Yeah.
Sorry to interrupt. Okay, that means we need to use a graph paper for this in exam.
Yes. Let me explain first.
I don't know how to do it.
Let me okay, just a moment. Let me explain this one first. So bihun you have 10, right? I'm going to put 10 here. I'm going to put 10, 10, okay? And then you have curry chicken you have 8, right? 8. Remember just earlier, I'm looking at the earlier one, the earlier one where we use the pictogram to find out how many people like the kind of food, isn't it? Okay, I'm using this, yeah? Okay, I'm using this data, okay? Has to draw the horizontal bar chart. So this one you have 8. Okay, and the final one, maybe you can tell me how many people like fishball. Can you tell me how many people like fishball?
5.
5? How do you know it's 5? How do you know? Because you see, this is a 4 here, this is a 6 here,
Because
right?
there's a half here in between.
Yeah. So you have a 4. So if you are drawing a chart, okay, you are drawing one now. Normally in the exam, they will give you something like that. No? In the exam, if they ever ask you to draw in the exam, they will give you a bar chart, okay? They will give you a graph paper. No, they'll give you a graph paper. Maybe I don't want to use this. Hold on. I'm going to change my screen of sharing. Easier for you to see. Just hold on. I'm going to switch over first. Okay, just give me a moment. I'm going to stop sharing. I'm going to change it to screen. Okay. Okay, I'm going to share by screen, easier. Screen, okay, I think you all can see it. Same thing. It looks the same to you, but my sharing right now is different. Now, in the exam, they will give you a graph paper, no? Something like that. This is a graph paper. So when you look at the graph paper, you must know what to do. No? You don't look at the graph paper, what is this for? Okay, the graph paper is actually meant for you to do this. I go back to my screen again. Your graph paper actually allows you to, let's say, for example, they ask you to draw. Okay, can you draw a representation of the data? They give you a representative data, and when they give you a graph paper, then how do you draw? Now, let's say, for example, if I look at the data. Okay, I look at the data. My data is 12, 10, 8, and this one is you all know that it's 5 just now, right? So if I look at this one, the number is very small, no? So if I want to draw a graph, now if I want you to look at this graph, okay, I want you to look at this part of the graph, the graph on top of the Lhasa. I want you to look at on top, okay? I'm going to do some representation for you on top. Now, if I say right now I want to draw a graph of this kind of representation, it's up to me to represent. You can see how do they represent? They actually represent every 5 bar. You see, every 5 bar they take it as 1. You see, because I have 12, so they'll take 1, 2, 3, 4, 5. Every 5 bar they represent 2. Okay, so this is 2. So one bar consider how many? So 4, 5. Every difficult to count, but they know that because this is an even number, so since this is an even number, they try to divide as even as possible. If I have the maximum of 12, they do this, or they take every 5, 1, 2, 3, 4, 5 to represent 2. Okay, so this is 2. If you have a 2 here, it is good. The all rest must be the same. You cannot say from here to here you have 5. Every 5 square you represent 2, and then this one another 5 square become 3. And this one become 6. You can see the number become very uneven, isn't it? Your representation must be the same. Okay, so if I'm going to use the representation to be every 5 squares to be 2, then it must be all the same. So from 5 square I will count 1. I will count 1, 2, 3, 4, 5. I have a 2. Then count 5 again. 1, 2, 3, 4, 5. Another 2. Another give you 4, isn't it? So the same thing all the way to 2, 4, 6, 10. That's why you have a 12 in the end. Now, how do you represent? Up to you. Some people, because you can say that, oh, maybe 12 a bit too big, too small. Okay, they want to make it bigger. You can actually represent one. You can take a 1, 2, 3, 4. 1, 2, 3, 4, 5. You can put 1 if you want to. Okay, then if you have 1, then again 1, 2, 3, 4, 5. Then become 2. But you can see that if I draw 12, you might not even reach to the end. You have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's say, for example, your graph is very small. They give you a small graph paper. If you use every 5 square to represent 1, you might not have enough to draw 12, isn't it? Am I right? So you say, wow, like that, too small, not enough space there. So in that case, you look at it, you're gonna make it smaller. Instead of having every 5 square represent 1, you use 5 square to represent 2, like they are doing here. It's up to you, Some people, let's say, for example, if I give you a data, I give you another example. Let's say I give you an example. I give an example. Now, let's say, for example, I instead of having 12, example is instead of 12, I say 120 students. I change. I say, okay, Laksa, 120 students like Laksa. 100 students like, I add a 0 in front. 80 students like curry chicken, and 50 students like a fishball. Then I ask you to draw. Then how do you draw? How do you draw this? Because you look at it, the number is so big, right? The number is so big. How do you represent? If I have 120, and then it's up to you already. If I take everybody 10, let's say, for example, I take this is if I want to make it very big, I can make it like that. I can make it 0. This one could be 0 here, 0 here. It can be 0 here. Start from 0. Then every 5 square it will be 20. So it will be 20, 40. Every 5 square 60, 80. Then 100, every 5 square. Can you see? Then another 5 square, I have 120. Why? Because in other words, I'm taking every 5 square to be 5 square is 20. Why do I want to do that? Because the number is too big. I cannot afford to make every 5 square 10. If I make a 10 square, again, the same thing. The number will stretch all the way to the outside. Not enough space, isn't it? Right. So how you represent the square depends on the data that give it to you. Do you understand? So if I have 120, because and at the same time, you also try not to make it too small. For example, you don't go and draw. Okay, I want to draw this 120. Then you take 120. Very small. But the number is very big. So what I'm going to do is do this. Okay, every square I represent 10. So this one is 0. This one is 10. Another square 20. This is no good. You know why this is no good? This one 30. This one 40. This one 50. This is no good. And by the time you reach here, this is 100. Then 120. This is no good. You know why this is good? This is too small. Okay, one small square you represent 10. This is no good, isn't it? Right? So you try to make your graph to be proportional that people can see. They actually want to. Yeah.
Mr. Wang, if they give the graph paper for us to do it, if it's very small, how to count? If it's very small,
you have to count. So they give a graph paper like that. Say for example, okay, they give a graph paper like that. Okay,
you show the original, then we know.
Let's say this one. Let's say they give you this one. Wow, this one how to square. Then you got to start to count. They give you a square. The graph paper is something like that one. Yeah, can be as small as this. Yeah. So you got to count up to you. One, you see the square is very big. Maybe I magnify the square. See whether I can magnify the square. The square. Okay, maybe I magnify the square to be like that. So you got to count. Up to you to do. You can say, I can actually start from here. This is a 0 point. Maybe I use a draw mode. I can take, this is a 0 point. Okay, this is 0. So this is 0. So this one, I can take one square to represent 10. Another one 20. But this is no good. You know why? Because too small. This one 40. 40. This is 40. It's no good because it's too small, isn't it? So you might want to change. Let's say, for example, this is too small. So you change your method. This is too small. Now, since I want to represent 20, I can actually make it to be every 2 square, 1, 2 to represent 10. This is 10. 1, 2, 20. 1, 2, 30. This is 30. 1, 2, 40. 1, 2, 50. 1, 2, 60. 60, then this is 70, this is 80, this is 90, and this is 100, this is 110, this is 120. Can you see, right? So this is more logical. This is more logical. No? So if I ask you, okay, from here to here is 10. Then in the middle is what?
5.
5, lor? Yeah. So between 0 and 5, in the middle is what?
5 is 2.
Huh?
2.5, sir.
2.5, lor? 2.5, lor? 2.5. So you must know your representation, okay? It all depends on you how you want to draw a graph. No? You don't make it too small, you don't make it too big. So you understand what I'm saying? So when they give you a graph paper like that, it's up to you to draw, okay? It's really up to you to draw. Yeah, I'm just trying to show it to you in a bigger square only. But it's the same, the squares are actually very small, okay? So if you think the square too small, then you make it bigger. 10 square to represent 1. I can actually make it like that also, no? I can make it, this is 0, 0. So I count, 1, 2, 1, 2, 3, 4, 5. Every 5 square, I consider 10. So 1, 2, 3, 4, 5, 20. 1, 2, 3, 4, 5, 30. So in this case, you spread out the data, right? But if you take every 5 square to represent 10, if I have 120, I don't think you have enough space for you also in the end. Am I right? Okay. So it all depends on you. You must look at the data that they give to you. Then you decide how many square represent the data that you want to present. Okay. So back to this again. Yeah. So now, do you know how to draw graph? Anybody? You okay now?
Mr. Wong, this
Yeah.
graph is only for the graph figure. Then we only have to do only for graph,
Yeah.
right? No other.
Only for graph only for data representation, statistic representation.
But in exam, when they show, right, how many cans or something like how many, I mean, like this in the screen, so they never show any amount. We have to write ourselves, is it? Or
Oh
they will indicate?
you have to write it yourself. You got to draw line yourself. For example, let's say in the exam.
So, was there any indication say that okay, 1 represent 5, so we have to draw ourselves?
Oh yeah, they'll tell you. You have to tell them how many square. In fact, you don't have to, because they can see when they look at the graph, they can see your representation. But if you want to be clear, you can actually, let's say for example, after drawing,
okay,
after drawing, you can actually tell them that okay, every 10 square equals 10 square equals to 1, if you want to. But normally people don't do this, they actually look at a diagram, they know, they will know. I don't think you need to even do this. You don't need to tell them your representation, because when you start to count, when you start to do your counting, let's say you draw a line, you put they will be able to see your representation one. But you got to make sure your representation is correct. That's important. Okay, right? Is it all right? I give you one example. Let's say, for example, I give you okay, I give you an example. Let's say I have 4 data. Okay, I give you Lhasa again. I give you another one. Lhasa. Lhasa is it? Lhasa, I have 1,000 people. 1,000. Okay, 1,000 people like Lhasa. And then I have Mee Siam. Mee Siam, I have 2,000 people. 2,000. And then I have Bee Hoon. I have 1,500 people. These are represent of people. Okay, people. And then I have the last one, the kind of food, roti prata. Roti prata, we have 1,750 people. So these are the number of people. So I ask you to draw, okay, do a representation of such people. Wow, I said, wow, how to represent like that? You see, there are many ways of do representation. No? You don't really need to, when you have a graph like that, wow, then how to do representation. Let's say you want to draw a bar chart. Where do you go? Let's say you want to draw a bar chart. Wow, like that, how to represent? Must I start from 0 now? Wow, start from 0. So this one is 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. So let's say, for example, this is 1,000. 1,000, okay? And altogether, you have 2,000. Yeah? Then you have 110, 100, 100, 1,100, 200, 1,300, 1,400, 500. Let's say altogether 1,200, 2,000 here. Let's say it's 2,000 here. Okay? Okay, for example. So you can see your bar graph become like that, Your laksa, this is laksa, this is your mee siam, this is your bihun, this is your prata. So your bar chart for laksa is 1,000. So your laksa become like that, Your laksa is here, your laksa. And then your mee siam is 2,000. Your mee siam is here. Mee siam is here 2,000. Okay, all right. And then your bihun is 1,005. Your bihun 1,005 until here. Okay, around here. And then your roti prata 1,700 represent here, around here. Okay. Oh, so you notice all your data is around here. You notice that. And then this one over here actually nothing. Isn't it? It becomes very unnecessary, right? Since your number is all at the back, you don't even have 1, 2, 3, or even 100, 200, 300, But your data is go by the 1,000, 1,000, 2,000, 1,000, 2,000, 1,005, 1,007. So your representation become all at the back, whereas in front become empty, So what do? You don't really need to start from zero. I'm trying to tell you, you don't really need to start from zero. Let's say, for example, you have a data like that. You can actually make your data to be like that. Let's say, for example, I change. You can make a data like that. Let's say I draw a graph like that. I draw a graph. Okay. You can.
Mr. Wong?
Yeah.
Just now you draw the graph, right? 1,000, 2,000. So that is exactly what we need to do in the exam, right? In the graph paper.
Yeah, correct.
That is how we have to do because last time when I sit for the exam, I never do anything. I didn't know how to use the graph.
Yeah, you can use depending on depending on what they want. They might give you a graph paper in the end, you never use it because I mean I don't know. Sometimes they just give you a graph paper only. You might not even use it. Yeah, they just give you just in case because they don't know what kind of question is going to be set. So they give you just in case. You might not even use it. I don't remember you need to use it. In fact, during your time, Manjula, you're giving a graph paper. I don't remember you need to use the graph paper. I don't remember.
Yeah, there's a bar chart, but because first time sitting down, so I really, I don't know how to do it, so I just leave it blank.
Okay, so in the end, so in the end, when you draw a graph like that, I told you altogether it's between 1,000, 1,000, you have 1,000, you have 2,000, you have 1,500, you have 1,750, 150, right? You don't really need to start from zero, You know, I'm trying to tell you, You can actually start from 500, Okay, this is 500. The first, the center point here is 500. So 500, so maybe this is 500, this is 700, this is maybe every time is 700. This is depending on number of square. This can be 700. Every time you add 200, this is 900. This is 1,100. Depending on number of square, like I say, your square must be the same. Your number of square must be the same, okay? Right? So this one, another one could be 1,300. This is 1,500. 1,500. This is 1,700. This is 1,900. This is 2,100. So you can see here, since the number is between this 1,000 and 2,000, I can actually start from 500 first. And then every 20 square, I represent 200, okay? Every 20 square, for example, every 20 square, every 20 square, I can actually represent 200. So you have 20 square here, 20 square, they are all equally divided. In the end, you have 500 to 2,100. So you can see you don't really need to start from zero. Do you notice that? Yeah, you don't have to start from zero if you want to. You say, okay, now you understand how I draw a graph. The graph is up to you to interpret one, up to you to draw one. You must be able to draw a graph to represent the data. As long as you can draw the graph to make it in such a way that you can a proper graph, Okay, this is a very simple graph, Now I can start from zero. Why is it I can start from zero? Because the number is very small. Because the number is this is only 12, This is only 10. This is only 8. This is only 5. So I can start from zero. Am I right? Yeah, makes sense to you now. I can start from zero. But if the thing is 1,000, this is 2,000, 20. How can you start from zero? You start from zero. Your graph is all on the right. Your front part all nothing one. Yeah. Then this kind of a graph are not very good. Not very good to represent a graph. Is it okay? Do you understand? Just say it, all of you. Yeah. Question.
No question for now.
No question from now, okay? So you will have to like Manjula mentioned they will give you a graph paper. You must know how to use
Yeah.
the graph paper. Yeah. If I don't look at the graph paper, what is it for? Yeah, okay.
Yeah,
Yeah,
because first time when I was doing exam, because
yeah,
nobody
yeah,
knows how to do it. So suddenly they give the graph
yeah,
paper. So
yeah.
now I know how to do it because now you're already teaching us, you see, how to use the graph paper.
Okay, now this is the bar chart. Okay, this is called horizontal bar chart because the bar is horizontal. Then what about what about vertical? Vertical is like that, no? Yeah, vertical is like that. You know, notice that, yeah. Okay, vertical is it's just that they turn the bar the other way around lah. Actually, you notice it's the same thing. You know, you still have Lhasa lah. So instead of Lhasa, you still have the same thing. But instead of having the data horizontally, instead of having two, 4, 6. They do the number in the vertical order now. Yeah, it's the same. It's either whether some people like to use vertical bar chart, some people like to use horizontal bar chart. Up to you, you know. But in the exam, make sure you know what they want now. They ask you to draw a vertical bar chart, you give them a horizontal bar chart, then you get nothing in the end. Yeah. So this is a bar chart. Normally bar chart is used to represent what? You represent item lah. Okay. What is this item? Oh, this is Lhasa. You used to represent item lah. One item. Bar chart you used to represent item lah. Okay. So whether you're using vertical bar chart, whether you're using horizontal bar chart, the x-axis and the y-axis is used to represent item. And if they question in the exam, they ask you, x-axis is this, y-axis is this. Can somebody tell me where's the x-axis and the y-axis or not? Anybody can tell me the x-axis and the y-axis? If you okay, the favorite food the favorite food is x-axis or y-axis?
X.
Huh? X-axis and y-axis Suddenly I forgot.
Sorry, Mr. Wong.
Why,
can you
sir?
repeat again?
The other one
Huh?
X.
Where's the x-axis?
Why is that? Sorry.
Why number
Oh.
is it?
No. I think this is the y-axis. If I'm not wrong, this is the y-axis now. This is the x-axis. This is the yeah. Okay. All right. I can check. You know, later on I double check. Can't remember whether. Okay. If they are talking about the y-axis is always the vertical line. X-axis on the horizontal line. Is it okay? Yeah. If they ever ask you okay, oh, x-axis, I want you to use this. Y-axis, use that. So you must know where is the x-axis and the y. Yeah.
Mr. Wong, you're correct. The y-axis is at the top. the
Vertical.
x- Yes.
Am I right? This is y. Am I right?
Yes.
This is y. Yeah, something that I forgot. You know, I never draw this for so long. So okay, you checked for me already. Is it Hazima? Is it?
Yeah. They're
Thank you.
roughly. Yeah.
Thank you very much. Thank you very much. Okay. Confirm. Your y-axis is always the vertical line. Your x-axis is always the horizontal line. Just in case they ever ask you, yeah. X-axis, they'll tell you how many to if they ever tell you, to represent what, how many square, how many unit to represent what, then they say, x-axis represent this, y-axis represent that, so you must know where to draw. If they say, okay, x-axis represents student, so make sure this is student, y-axis represent the food, so make sure this one is the food. Yeah. Okay. Yeah. Right. Okay. Same thing back to this. All right. This is x-axis represent this is the other way around. X-axis represent the food. This one y-axis represent the student. Okay. Axis talks about axis talks about a x I x a x a x I x. Okay. That's x-axis. Yeah. So right, you have the two bar chart. Now notice that the two bar chart, the width of the bars are equal and they are equally spaced. Normally bar chart, they are the width is the same. This is called the width. Normally the width is the same one. Okay, if you ever you can see that the width is drawn equally. Okay, so don't go and draw things like that. When you draw a bar chart, okay, represent the food. You don't go and draw like that. Example. Okay, the Lhasa is so big. Okay, Lhasa. Let's say Lhasa, draw Lhasa. Lhasa, the square is like that. Okay. And then when you draw the Lhasa for bihun, the bihun is so thin, the bihun so thin. And then you draw the curry chicken, curry chicken is so fat, even thicker than the Lhasa, very thick. Yeah. And then you draw the fishball noodle bar represent one thin line. You make sure that the width is the same. Notice that the width is the same. Okay, right? Okay, notice that the two bar chart, the width of the bars are actually the same, equally spaced out. Okay, the height of one column of the length of the bar represent frequency. The frequency means how many lah. The word frequency here talks about how many. Okay, how many times, how many students, how many times, the height of one column. Yeah, so one column must represent the height of the one column. This height actually, they say 12. This one must be 12. Okay, this one must be 12. So this is 12. If this is 10, 10 must be close to 10. So that's why you put the number on top. So this is 8, so that you don't have to every time you measure. This is 5. So when you're in the exam, they give you a diagram like that. It's good that you put down the number on top. You can write on the paper if you want to. They will allow you. Okay, write the number on the bar so that you know, instead of always looking left, right. You look at the number, you know how much they represent. Is it okay? Alright, okay. Alright, let's do something. What example? The bar chart below shows the number of hour each student. This is a bar chart, okay? Yeah. You can see bar chart use individual item lah. Is about individual item. This is individual student. Notice that? Okay, the individual student. Alright. Number of students represent learning Chinese calligraphy per week. Okay, let's look at the question. Find the number of hours they spend learning Chinese calligraphy. Or define a total number. So in order to find the total number of hours, what do you think you need to do? Of course, you can do like that. You can draw the line down. You can draw the line down. But very leceh, you do that. Very leceh, very troublesome. Yeah. So what do? It's always good. You write the number on top of the bar or beside the bar if you want to. It's always good to write. Then you don't have to refer it all the time. So you look at the first one, Julie. This one represents hours. The x-axis represents hours, right? The x-axis represent hours. So this is a y-axis. Y-axis represents student. So Julie spent how many hours, Julie? 3, right? You look at the bottom. There's 3. So it's good that you write on, either you write it inside or you write it on top or beside. Like you can write 3 if you want to, or you can write inside if you want to. Up to you, really. As long as you can see, it's really up to you. Yeah. Some people like to write it on top, so that you know that you can see the number clearly. So this is 8. The second one is calligraphy, right? This is 8. This is novice is 7. This is 4. This is 5. So the first question, very easy. Find the total number of hours they spend. You just add them together, isn't it? Right? So you have 10, 18, 22, 27, isn't it? You add them out, you get 27, right? Yeah, that's how we do it. Find the average number of hours they spend. What is the average number? How do you find?
27 divided by 5.
You have, first of all, you total is 27, isn't it? Yes. 10, 18, 22, 27. So total is 27 hours. Total is 27 hours. How many people altogether? The word average means roughly the number of hours one person will spend. Because some people will spend more, some people spend less. So if the total number of people of 5 people spend 27 hours, what is the average? Then divide by 5 lor.
Divide by 5. 5.4 hours.
Then you have 427 divided by 5, 4 and 520, 525, yeah. 5 and 5, 25, right? Yeah. 5 and 5, 205 hours, which is 5.4 hours, right?
5.4 hours.
You change, I'm very sure you know how to change this to decimal places, decimal point, right? Okay, so anyway, you take your calculator, 27 divided by 5, you get 5.4 hours. Yeah, so that's average. Yeah. Find the difference in the number of hours spent by Mavis. Mavis and Jacqueline has a percentage of the number of hours Jacqueline spent. Okay, so okay, this one find the difference in the amount of time spent by Mavis and Jake. In this, I think they're asking you the total. No, I don't know exactly what they ask. You see, the last question. The difference in this case, they find the difference between find the different amount of time spent by Mavis and Jacqueline as a percentage of the number of hours Jacqueline spent. Oh, okay, between these two persons. Oh, I see. So what they want you to do is they ask you, okay, you look at Mavis first. Mavis spent 7 hours. Yeah. Jacqueline spent 4 hours. Okay. The difference between the amount spent between these two is actually 7 minus 4. We all know 7 minus 4 isn't it, right? And then they ask you as a percentage of the number of spent Jacqueline spent. So first of all, you find the difference, which is 7. The difference is actually 7 minus 4. That's the difference. That is the difference between 7 minus 4. Oh, cannot draw suddenly. 7 minus 4. Divide by the percentage, has a percentage of the number Jacqueline spent. You all know Jacqueline spent
100.
you need to
You have
100 because you need to change the percentage. Yeah. Okay. So they ask you a question like that. Yeah. You just need to know what need to figure out exactly what they ask. Okay. What they asking. So these are the questions they will ask. Using graph to ask you question. Yeah. Okay.
Mr. Wong, you put as 7.4, is it?
Is it 7.4? 5.4. 5.4. What's 7.4? 7 minus 4. 7 minus 4.
Okay, because you put a dot, I thought.
Okay.
3/4.
Hold on. Just a moment. Look, you all look at this first. Okay. Yeah. Question? Anybody want to ask any question? Yeah. Okay. So what? Okay, another example. Maybe we do this. Another example. 6 chicken rice store in a food center will survey 1 A, B, C, D. Draw a vertical bar now. This is the question now. Vertical bar. You must know what the vertical bar is talking about. Show the number of plates of chicken rice sold from 6 different rice stores in the food center in a day. Now they give you this, use a scale. This is where your graph will come in. Use a scale of 1 cm to represent 50. You see, look at the number. The number is very big. The number is very big now. So you cannot use the too small. 1 cm represent 1. The graph will become very big, right? Since the number is so big, they ask you, you're gonna take a ruler. So you gotta take a ruler. You use this. Then you gotta measure. You gotta measure already. Okay, how do you measure? Then you take every 5 cm. Every 5 vertical bar, isn't it? Every 5 cm. 5 cm. Let's see, you measure 5 cm. Represent how many? 5 cm. 5 cm represent 50 plate. 50 plate. So it become like that. You ask you to draw. You need to draw. This is become 0. This one 50. Then another 5 cm. 100. Another 5 cm. 150. Another 5 cm. 200. Another 5 cm. 250. Yeah. Okay. You understand? All right. So when you draw like that, you put down the number. You put down the number. Why 5 cm? Because they ask you to use 5 cm. But sometimes they can actually ask you to use 10 cm also. I'm up to them. Go look at the question. In this case, I start from 0. All right. I start from 0. If you don't want to start from 0, also can. You can actually start from 50. You can start from 50. You start from 50, then the line is here. Okay. If you start from 0, then the line is below. So it depends on where you want to start. But if the number is quite close, 50, 100, 150, 250, then it's okay. You can start from, because after all, the number is actually close to 50. 50, actually 50 quite far away from smallest number. Your smallest number is actually 140. You notice that? Yeah. So you can use a bar chart of, 50 if you want to. So instead of starting from 0, you can actually start from 50. You can start from 50. Yeah. Okay, right? Start from 50. If you want to, up to you. Like I said, it's really up to you how you want to interpret. You want to draw a nice bar chart, right? So really up to you how you want to draw. Yeah. So you want to start from 50 also can. You want to start from 0 also can. 0, then you draw below, lower down. So your horizontal line is the one you start from here. Then horizontal line becomes 50. So it depends on from where you begin with. You start from 0, so your horizontal line will be here. Yeah. Something like that. 50. Yeah. Okay. If you want to start from 0, then you will have to take this away. Then you have to draw again. Draw again, then another 5 start from here, 0. Then your horizontal bar will start from here. Okay. Yeah. You understand? You understand how we draw a graph? Yeah. All right. Come back to this again. Yeah. Draw a vertical bar chart to show the number of plates. Use a scale of 1 to represent 50. So if I ask you to draw, can you draw or not? You don't think you can draw this or not? Draw a vertical. So your bar chart is like that. You draw it's like that. Yeah, it's a vertical bar chart. Okay. This one will be store A. You can just put A. B, C, D, vertical bar chart. So this one you can put the word number store here. You can put the word store. So store A, store B, store C, store D. Plates, since I want the vertical bar chart, okay, you can put the word plates. Plates. Then you draw the number there. Okay, all right. See if they have any answer. Yeah, here you are. Can you see? Yeah. Okay. You can see they start from. Actually, you don't have to put like that or store A, store B. You can just put A, B, C, D, and then put the word store below. I think I thought it looks neater. Yeah, but up to you really. Yeah. So you can do this. You can do the method I use also. Now they start from 0. You notice they start from 0, right? If you want to start from 0, also can. If you want to start from 50, also can. So in your x-axis will be from here. The x-axis will be from here. So this one become your x-axis. Yeah. If you want to start from 50, up to you already. Yeah. As long as your representation is correct. So you can see they say 5 cm, right? Every 5 cm is 50. So if you take your ruler to measure from here to here is actually 5 cm. So every 5 cm 50. So your spacing, your division must be the same. So every 5 cm 50, so you'll be 50, 100, 150 all the way to 450. Then you have a drawing. Yeah. Any question? You do not use a bar chart. Use the graph or not? I hope you know how to use a graph to draw. I think.
Mr. Wong?
Yeah.
So the drawing just something like this will do already, right? Don't have to be so, I don't know, like complicated or that one?
I don't know what about complicated. How complicated? Yeah.
I mean, like, must it be like this? Must it be drawn like this accurately or not? Like.
Oh, you need to be accurate one, no. You need to be accurate. You cannot anyhow draw one, no. You cannot use your free hand. When you're drawing a bar chart, you need a ruler, no. You need a ruler. You cannot anyhow draw, no. Because when they ask you to draw this representation here, 1 cm, every 1 cm represents 50 players. So this one considered 1 cm. Oh, my mistake. I was talking 5 cm. That means this is considered 1 cm, no. This is 1 cm. 1 cm, 1 cm, 1 cm. It must be accurate. It must be accurate. You cannot anyhow draw. No, you cannot use agar. Cannot. No, you must use a ruler because when they give you a graph paper look like that. Okay, so you need to use a ruler to draw. No, you need a ruler like that. Draw straight line. Okay, then you're gonna measure. No, every 1 cm 50. Then you measure again. Every 1 cm another 50. At 1 cm another 50. Every cm 200. You must make it accurate. You cannot say any agar. And then when you draw the bar, remember I told you the bar just now. The bar, make sure the width is like the same. You don't want to draw a bar, some very thin. Some very thin. Some become very fat. Very fat. And some very thin again. Now this one draw you will fail. Your width of your bar chart must be the same. Your width must be the same. You can see the width, some very thick, some very thin. Cannot, okay. Even though your measurement is the same, the number is the same, but your width is different, that's no good. So it must be accurate, Darwin. You cannot say it will not be, it is not accurate and agar cannot. No, it must be accurate. Okay. So back to this again. So that's the first question. Which store has the most? Which store has the most popular? What's the most popular? Now, okay, you can actually look at the bar chart if you want to. Okay. Let us answer the first question now. Which store was the most popular and which store was the least popular? So you see, when you look at this, sometimes when you ask a person, this person need to look at the number. Very difficult to see, right? But when you look at the bar chart, it's easier to see now. We know that this is the most popular, this is the least popular. By looking at how high, how tall, how long, how tall, how short, isn't it, right? So we all know that the most popular is store F, the least popular is store A. Yeah. So that's the answer, store F most popular, store A was the least popular by looking at the bar chart. That is B, A, B, C. Find the average number of plates. So how do you find the number of average? All you need to do is to add the total, all this plus this, add them all together, then divide by how many? You add them all together, plus.
Yeah, by 6.
Yeah, by how many?
6.
Yeah, by 6. Yeah, by 6 in the end. Yeah, that's average. Okay, last one. One plate of chicken rice in store A costs $3.50, whereas one plate of chicken rice in store B costs $2. Find the difference in earning. Okay, what do you do? Yeah, how much they earn? So how do you do this? Store A. Okay, if maybe store A is $3.50, store A is $2. So I look at this. Store A is $3.50, right? So this is $3.50. Maybe I erase this first. Okay, all right. Okay. Store A, and this one is $3.50 for the first one. So I put $3.50 here, one plate. $3.50. $3.50. Store E is $2, right? Is it store E $2? $2. So what do you do? If in the end, this is considered one day, one day, is it? Number of plates 1 day, is it? Number of plates sold in 1 day, in 1 day, correct? It's 1 day. So what you want to do is you want to find out how much he earned. How much he earned depends on how much he sold the plate, isn't it? So this is how many. Okay, if I ask you, this one is 150. How much is this? Can somebody tell me?
Which one, sir?
A, 100, 110, 100. Okay,
140 times 350, sir.
100 what?
40
140.
140.
times 350. 420, sir.
So this one is $3.50. This one $3.
Yes, sir.
Minus 140 minus 50.
So you will have to take 140 times 350 total, right? And then
Yes,
this
sir.
one store E is $2. $2, how many plates you sold?
360, sir.
360. So you got to take
Yeah.
360 times 2. So you will do this 140
Times 2.
times 350.
720.
Okay. 350 minus 360 times 2. That is the difference they earn, no? Am I right? Am I correct?
Yes,
Okay.
sir.
So this is that's the question they asked lah. Find the difference. Yeah, find the difference in the earnings. So store A earns so much, store B, store E earns so much. You just have to times and then you minus, you get the answer. Yeah, same thing. Yeah, the difference is this: store A earns so much, store E earns so much. Then you minus them together, you get the difference. So which store earn the most? Of course, in the end, which store earn the most?
E, sir. Store E.
E. E.
Store E, sorry. Store
See,
E.
you look at store E. E only sell $2. You notice that E sell $2. Whereas A sell $3.50. So you can see those people rather buy the cheaper store than buy the more expensive. So don't think that if any one of you happen to be a store holder, you're going to sell more expensive. People won't buy from you, no. You notice that. But if you sell cheaper, people will buy from you. Yeah. So in the end, you earn more. Okay. All right. Yeah. So this is a smarter guy lah. Store E is a smarter guy. Reduce it, okay. If he's smarter, maybe I'll charge 250. Then even earn more. As long as it's less than 350 lah. If that guy selling 350, make sure I sell lower than that, then people will buy from me. But of course, my quality cannot be compromised. It must be as good as his. Okay. All right. We have done your bar chart already. We have done the pictogram. We have done the horizontal bar chart, vertical bar chart. Now we do the pie chart. Pie. The word pie here means that eat pizza. So that's a pie chart. Now normally when do you use a pie chart? A pie chart is a circular. This is a pie chart. Okay. It's like a wheel. No. It's a circular chart with different segments. Each segment is called a sector. Okay. So you have a pie chart. They use a pie chart to represent many things. Some people like to use represent a percentage. Okay, so percentage. This could be okay. Maybe if I ask you to percentage. Percentage you don't think that it's 360 degrees. It's only 100% only. So this could be 50%. Oh, no. If I have a pie chart like that. Okay. This could be 45%. This could be 30%. This could be 20%. And I'm all up together, it should be 180%. 100%. What am I talking about? It should be 100%. So it is not about your degree of 180 or 360. It has nothing to do with 180 or 360 degrees. So don't think that, pie chart must be 360, okay? But when you talk about percentage, it just has to tell you how big is your pie only. So if I ask you to represent 50%, 50%, your pie chart to represent 50%, it will be, how does it look like? Okay, if I say, okay, I want you to use a pie chart to represent 50% of them are students, okay, 50%. So the rest, 20% are teaching staff. Okay. So 50% are students. So 50% are students, actually half. So this is student, this is 50%, so this is student. Okay. And then 25% is academic staff. 25%. That means this one, 25%. This one could be teaching staff, teacher. And then you have another 25% of maybe you have another 10% cleaning staff. You have 10%. Okay. So add up together, then the rest it could be you have 50, 60, 70, 80. Then you have another 15%. This could be a cleaning, this could be the academic staff. So total, it must be 100%. So don't think that a pie chart necessarily must be 360 degrees. 360 degrees to represent 100%. Not true, okay? The whole thing itself actually represent 100%. Yeah. All right. Okay. All right. The angle of a sector is used to represent the frequency. The word frequency means again, the angle itself. The angle, when they talk about the angle, they actually talk about this angle now. This angle. This angle. This is the angle they're talking about. Okay. All right. So this one represents the frequency. The frequency normally is used by percentage. But percentage, the whole circle, of course, we all know represent 100%. Okay. But if you want to call about the degree must still be 360. That's why you can see a 360 here. Okay. Because you know why? When you want to divide, you must have divide by the number of, when you're using degree to be the percent, you make sure you have the 360, but the whole thing represents 100%. All right. The whole thing must represent 100%. So okay, if you want that, this will give you the angle. If you want to measure the angle, this will give you the angle. Okay, all right. Yeah. So what does it mean? It means that okay, if I give one example. Okay, so if I say okay, let's say I have altogether in the school, I have 100 staff. I have 100 staff. In the school, I have 100 staff. Okay, and there are 50 students. In the school, there are In the school, there are 100 students, but 50 of them are staff. So what is the angle to represent? Let's say what is the angle to represent in the if I need to draw a circle, what is the angle that you need to present? Then you take 50 divided by 100 times, because the total circle is 360 degrees, isn't it? All right. So when you take this, this one will give you what?
180, sir.
180, right? So that's why I say this one becomes 50%. You can see that this is a 50%. So this is actually 50%, but the angle is 180. Is it okay? Yeah. The angle itself to draw is 180, but the percentage wise is actually 50%. This is actually 50%. Yeah. So just in case they ever ask you to draw angle, instead of using percentage, they ask you to use angle. The moment you use angle, you use 360 already. But when you're using percentage, it's the other way around. You notice that 180 degrees is equal to 50%. In other words, it's as good as saying 180 degree is equals to 50% for when you want to talk about the percentage of a circle. Okay? Is it all right? All right, let's do one of these. This one example. Okay. A small guest house recorded the different nationality of a guest staying in it. Guest house is a hostel. Okay, this is a hostel. There were 75 Canadian, 125 European, 75% 25 of them are Asian, 75 are American. You are supposed to draw and label a pie chart. You're going to draw a chart. How do you do to illustrate the data? Okay. So first of all, okay, you take the whole thing as 100%. You take this as 100%. Okay. So if I ask to count, what now? If I'm going to draw, on a pie chart, I need the degree, isn't it? Am I right? Or else how do you draw? If I want to draw accurately, how do I draw? I need the degree. So I take the Canadian first. The Canadian, they are all together 300 stuff. You know that when you add up together, you add the Canadian, European, Asian, American, add up together, give you 300 stuff. So this is the total. Okay, look at the first one. If I want to draw on the pie chart to represent the Canadian, how many are there? The Canadian are actually 75. Altogether, there are 75 Canadian. Can you see? Okay, the Canadian itself, there are 75 Canadian. But how many people are there? Altogether, there are 300. Altogether, 300. If I want to draw on the pie chart, I got to convert it into degree, right? So when I convert into degree, you need to times 360 degree. This is the way to convert it into a degree. And what do you get? You get 90 degree. So I know that if I want to represent Canadian, if I have a pie chart, if I want to represent Canadian, your Canadian will be 90 degree now. So this is Canadian. 90. You understand? Okay, that's how you draw. I think I have a below. Let's see Canadian. Can you see it's like that? This Canadian, 90 degree. Yeah. Of course, it can be anywhere. It can be below. It can be on top. Depending on how you draw. So you then they ask. Then you got to start doing the rest. How do you draw European? European you can see it's 125, right? So you take 125 divide by the number of people in the hostel, 300, total is 300, right? Times 360 degree, you get 150 degrees. So this is your degree to represent your people, okay? So you have Canadian 90 degree, American also 90 degree. Why? Because American also 75, you can see 75. Same. So this and this is the same. So you get both 90. Notice that? Both 90, yeah? So you have American 90 degree, Canadian 90 degree. It doesn't matter which one draw first. You can have European, Canadian, Asian, American, or you can have European, Asian, Canadian, American, or you can have anywhere. It doesn't matter. It doesn't matter which one comes first. As long as you can feel all the group of people on the pie chart, then that's good now. It doesn't matter which one comes first, okay? But the degree is important. The degree is important. I don't think they will ask you to do this. Because when you do this, you need a protractor. You need a protractor to measure. Please don't take my word that they will not come out. It can come out, okay? If they ever ask you to do this, you make sure you have a protractor to do, okay? Yeah. Make sure you know how to use the protractor to measure. If you don't know how to measure a protractor, then you cannot do this at all. Yeah. Okay. Anyone?
Sir, anyone? Sir.
Yeah.
Sir, the first one. Sorry. No.
Yeah. What is it that you're asking?
the American. So since
American 75. What about American?
half 80, no, sir, American 75, Canadian 75. So what I'm saying, the first Canadian is a right angle, right, 90 degree. Exactly, I joined the other one. I put American. I can that'd be easy for me. 180, the balance I'll do the 150 and 30%.
Of course, you
I mean,
can.
Canadian, any design can, sir. Okay.
You can. It doesn't matter which one comes first. Yeah. You can draw a pie chart like that. You can draw a pie chart. Maybe I draw and I draw one for you. You can actually draw like that
Okay,
now.
sir.
Say for example, okay, and then you draw, okay. This one 90, this one 90, this one 90, right?
Yes,
So you can put American
easy for
here,
me.
American here. This one can be Canadian. Also
Canadian.
can. Easier to draw, right? Easier to draw.
Yeah.
But not so
Yeah.
beautiful, lah. Not so beautiful.
Yeah.
But you can draw as long as you draw that the degree is correct. But easier to draw like that. Easier, right? Easier.
Easy, sir.
Yeah.
Hello, Mr. Wong.
Yeah. Sorry. Yeah.
This is Christine.
Christine. Yeah.
Yeah. Earlier, right?
Mm.
I'm still not so sure what you're like talking about.
Which one?
I'm not sure. Like, you get 90 degrees. Is it the question?
You're not sure of this one, is it? This one.
Yeah.
Okay.
Yeah,
Okay.
this card.
Okay.
You
It's
said,
okay. Oh.
do we need to calculate it?
Okay. Let me explain again. I erase all this again. Let me explain. Okay.
Thank you.
All right. No problem. I erase this again first. Yeah. Okay. Let's see what they want. Look at the question. Okay. You look at this question. They actually ask you, they ask you that, okay, in this hostel, in the hostel there are different group of people. You have 75 Canadian, you have you have 75 Canadian, you have 125 European, 25 Asian, 25 American. Okay. You are supposed to draw the chart to represent that on the pie chart now. Why pie chart? Because they say use pie chart, so you got no choice. So in this case, when they say draw, you are if you are expected to draw accurately, if you are expected to draw accurately, then you need to calculate, or else you cannot draw, no. So you need to calculate, okay. Draw means you can't agar, right? I don't think they will ask you to agar. I don't think so. They will probably ask you to draw it very accurately. When you need to draw accurate, you need to calculate with a degree. You need to calculate the degree. So how do you calculate the degree on the pie chart? Because we know that the pie chart is round. The pie chart is round, right? And we know that the pie chart is round. The total number of degree at the center of a circle is actually 360 degrees, isn't it? Am I right? Okay. So how do you represent like a Canadian, European, Asian, and American on the pie chart? The only way we can represent it on the pie chart is to calculate based on degree. So how do you calculate based on degree? I look at it. First of all, you need to calculate the total. The total is 75 plus 125 plus 25, and so the total is 300. Okay. So if I calculate the first one, okay, how many Canadian again? All the Canadian are 75. Altogether, the number of people, how many are there? The number of people is 300. 300. And I want to convert it to degree. I must times 360 degree. Why 360 degree? Because it's a circle. The moment I times 360 degree, what you're doing is you are actually changing it into a degree. You are changing it into degree. If I don't times 360, can somebody tell me if I don't times 360, okay? I say I want you. I change already. I change. I want you to tell me change to percentage. If I want to change the percentage, I cannot times 360 there. I should be times how much?
100.
Very good. It should be 100 already. If I want to change it into a percentage, I need to put it into 100. But when I put it 100, I don't get a degree. I cannot draw on the circle. I can only do it estimate only. How many percentage? I can agar only, okay? But when I change it into a degree, I can actually draw it very accurately on the circle. On the circle. Why? Because I convert it into a degree. When I use 360, I convert into a degree. And when I do that, for 75, I get 90 degree for the first one, 90 degree. For the second one, European, same thing. European, I have 125, right? I divide by the number of people that you want to calculate times 360, I'll get 150 degree. So for this 4 group of people, you get different degree. And when you look at this, you should be able to use a protractor to draw on the circle, how many degree. If I were you, I will, of course, how to do this? You use a protractor, get a center line first, get a center line, okay? Then you do, okay, so first one is 90 degree. I measure 90 degree, let's say. Then the second one, the 150 degree. 150 is normally from here. It should be 150 from here to here. So maybe another line, okay? All right, another 150. Then the next one is 30 degree. 30 degree must be from here. It must be from here now to here, 30 degree. Of course, the last one is 90 degrees. This one, okay? So to draw a circle, now you need to take a compass. You know what's a compass, right? Put the needle at the center with the pencil here. You draw a circle. You draw a circle. Then you have a pie chart already, isn't it? All this you just take away, erase away. All this erase. All the extra line erase away. Then you got a circle already, yeah? Okay? You understand or not?
So we don't have to use 100.
Sorry, say again?
We don't have to use 100.
Oh, no.
We use 360.
Oh, depends, you know.
Depends.
It depends, because if I ask you to draw on a circle, if I ask you to draw on a circle accurately, you need the 360. Why you need the 360? Because you need the degree, You need the degree.
Mm-hmm.
Yeah. But if I ask you to draw, okay, I don't want the 360. I don't need you to draw on the circle, but I want you to convert this into percentage. What is the percentage of 75, 125? Then you don't use 360 already, isn't it? You use 100, But when you use 100, you cannot really draw on the pie because they give you a percentage. You cannot really draw. You can't really draw, okay? But now after drawing, if I ask you to convert to percentage, you can convert now. If now you're European, can you convert now? You can convert now. All you need to do is just take the same thing. You just, let's say for example, the first one European, okay? You go, if I ask you to convert, write down on that pie chart and convert it into percentage. Can you convert? The answer is yes. You know that this is 75. European is 75. Canadian is 75, right? Canadian is 75, isn't it? So all you need to do is this. You just take
150 times 100, is it?
You just take 700. You just take 700. First one, Canadian. You just take 75 over 300 times 100. Then you get the percentage. Probably you get 25. You get 25%. Yeah. So this one, if I ask you, okay, change the percentage. How do you change percentage? You just take this one, 125 divide by 300 times 100. Then you get the percentage already. Then you write it here, So this one is 25%. This one is 25%. This one you calculate, yeah. Okay, you understand what I'm saying, So you can still convert. You can actually draw first by using 360. Is it okay? Yeah.
Understood.
Understood, Understood. Very clear. Understood. That's good. Okay. Yeah, look at the next one. Yeah. Another pie chart. Yeah. Pie chart is very good for percentage. In the exam, I ask you, pie chart is very good for showing you the proportion, How much is this one bigger than this comparison? Pie chart is very good for that. Did they say anything about how good is a pie chart? With a different segment, then it use the angle of okay. The angle represent frequency. Okay. Okay. All right. Samantha planned her time last Saturday has shown in the chart. Okay, this is Samantha pie chart. Sleep 1/3. Okay, sleep 1/3. Plan her time. This whole day, this is considered 24 hours, I think. I think it's 24 hours. But let us see first, okay? How much time did she spend on shopping, but nothing, what? Oh. How much time did she spend on shopping and entertainment? Do you think you can find this? Yeah. Based on what percentage? Is it percentage? I think the number of hours. What is this? Oh, I see. Because it's considered one whole. Now, if I ask you, okay, how much? Now, this is considered 24 hour. Yeah, this is considered 24 hour. This is 24 hour. So right now, they ask you, how much time did she spend on shopping and entertainment? Now, your pie chart can represent a lot of things. It can represent, I told you it can represent percentage, right? It can also represent one whole circle to be 1 day, 1 day, okay? So in this case, they actually should tell you the whole thing, because I noticed they use 24 hours. They didn't really tell you this is considered 1 day. They must actually tell you that this is considered 1 day. So when I know that the whole thing is considered 1 day, then every portion will be, if you want to change to the percentage, then depends on how many you times. Now, you look at the degree. This one is 90 degree, right? Total is actually 360 degrees. So they ask you, how much time did you spend on shopping and entertainment? How much time? You look at it, can you see the 90 degree there? Can you see a 90 degree there? 90 degree,
Yes.
yeah. You look at it, if it's 90 degree over the total, total is 360, isn't it? The whole day is 360 degree, right? If I want to find out how many hours, based on the hours, I will times 24, because the whole day is 24. So this one, I change it to 24. If it's 360, I change it to degree. If I change to 100, you change to percentage. So it depends on what you're measuring. Can you see that? Can you see that? Yeah. Okay. So if I ask you, okay, change it to how many times of how many days of the year, then I times 365 then 365 then become the number of days of the year. Okay. So this one, they ask you for the number of hours per the time, the time. So based on 1 day is 24, then I will times 24. Then you get 6 hours. You understand? Do you know why you use 90? Do you know why you use 90 or not?
Because 90 degree shown on the thing.
That degree is shown there. Yeah. This is very clear, right? Okay. The second question. Look at it. She spent the same amount of time on sport and revision. Sport and revision is this. Where's sport and revision? This one. She spent the same amount of time on sport and revision. How much time did she spend on sports and revision? Oh, this 1/3. How come? More time. Oh,
Yeah, Mr. Wang, the one they ask for sports and vision now, it says sleep.
yeah, different. That's why.
Different.
Yeah. Okay. I think this is wrong, I think this is wrong. This question is wrong now. It should be how much time you spend on sleeping. How much time you spend on sports and revision? Amount of time you spend on. Oh no. That's correct. Yeah. Amount of time you spend on sports is. Oh, I see. Well, this is a very tricky question. You don't look at the answer. You know what? You know what she's doing now? What she's doing is this. First of all, she find out how much time is here. The question asks you how much time you spend, amount of time you spend on sports and revision. These two together, okay? How much time she spend on? No, this and this is the same. This is equal. This is equal. These two are equal. Okay, all right. She spent the same amount of time on sports and revision. How much time you spend on sports? All you need to do is to find the two things together, and I divide by 2. Okay. Now I know that the first one, I already spend 6 hours. This 6 hours. Okay. And the second one, I know that I sleep 1/3, isn't it? But if I sleep 1/3, all I need to do is times 24. I will able to know how many hours I sleep. So I'll take 1/3 times 24, give you 8 hours. 8 hours. Now, the total number of hours is 24, isn't it? Whole day is 24 hours, right? So if I take the 24 hours, if I take the 24 hours minus 6 and minus 8, it will give you equals to 4, 5, 6, 7, 8, 16, 10 hours, isn't it? Altogether 10 hours, right? So you have less 10 hours for sports and revision. But we know that sports and revision is the same, isn't it? So all I need to do is divide by 2. I will get the amount of time for sports or revision, okay? So total in this case is 5 hours. Divide by 2 give you 5. Yeah? You understand?
So that means, Mr. Wang, you have to take the hours, take the 24 hours minus the shopping hours, minus the sleep hours to get the sports and revision.
Correct,
So then
correct,
they ask
correct.
for the same because they say these are the same. So you have to divide by 2 lah. It's 5 hours each, right?
Correct.
Oh, okay. Understood.
Yeah. Okay. Yeah, I think the first thing to do, they must tell you this is one whole day because I don't know the whole thing is one whole day. You know? So the last question, find the ratio of the hour. Find the ratio of the hour amount of time that she spent on revision to the amount of time she spent on sleep. So revision she spent on 5 hours, right? 5 hours, isn't it? Sleep is how many hours? Sleep is 8 hours or 5.
So
Ratio
5
is
to 8.
5 to 8
Yeah.
lah. Yeah.
Yeah.
Yeah. Is it okay?
Yes.
Mm. These are the kind of questions they'll ask you in the exam. Okay, yeah, they give you like that, nothing there, first nothing there. But I think they should tell you that the whole day, the whole circle is 1 day.
Mr. Wong?
Yeah.
1 sec, I still copying. Sorry.
Oh.
Oh, okay.
For revision, for sports, it will be 10 divided by 2, give you 5. Yeah. Because it's equal, man. Your sports and revision is equal. So you divide by 2. Yeah. Any other thing? Anybody ask anything?
Sir.
Yeah.
So I feel the hidden one is the sleep, sir. They already put the 1/3 there.
The trick is here.
No, I'm wondering the numbers. Why 1/3 they put there? And tip
Yeah,
one
actually,
thing. That's a very hidden, hidden to answer the sports and the revision.
Actually, there are 2 tricks here. The first trick is
Yeah,
the
1/3, sir. Now
90
I
degree.
realize.
The 90
The
degree.
90 degree and the 1/3.
And the third trick
So I
is
shouldn't. So Mr. Wong, I shouldn't look at 90 degree.
oh, you have to this time. This
I
time
have to.
because you need to, because this one for this particular question they tell you that you're supposed to calculate how many hours, right? But you look at the diagram and there's nothing there, but they give you a clue. What's the clue, Christine? What's the clue that they give you? The clue is 90 degree though.
90 and plus.
The clue is 90. So if I ask you how many hours is this, you will take 90 divide by total. 90 divided by what? Total is 360, right? The divide by 360, isn't it? But if I want to convert into hours, I need to times 24. Lor.
24.
Yeah. And when I time,
the 24?
do I need to what?
What's the 24?
Why 24? Because by calculating, it doesn't give you the number of hours. If I times 24, it will convert it to 24 hours. It is just like half times 24 give you what? Half times 24 give you 12, right? That means half a day, lor. It becomes half a day, yeah. If it's 90 divided by 360, it will give you 6, yeah. So this one 90 degree is actually 6 hours, consider. 90 degree is 6 hours, 90 degree.
So I have to calculate it. The total hour and the whole circle thing.
Yeah, you have to.
Mr. Wong?
Yeah.
At the 1/2 times 24, why is there a 12 there?
Why is there a 12 there? Oh, no. This one is just to tell you that if I have a half, I times 24, I give you 12, half a day, isn't it? So this is considered half a day. So if I have 90 over 360, I times 24, it will give you the number of days. This is just one example. It's just an example only. This is just an example. Just an example. Okay. So for all of you, if you ask me, now you look at this question, okay? If you ask me, if I draw a circle, okay? I divide by 1/4. This is 1/4. This is 90 degree now. So can you tell me every quarter how many hours is that? Every quarter.
6 hours, sir.
Very good. Every quarter is 6 hours. Very good. Yeah. Because you give you 24, isn't it? Am I right?
Yes, sir.
24, right? That's why you see when you calculate 90 degree, you get 6, because if you take 90, 360 divided by times 24, you get 6 hours, which is a quarter of a day. Yeah.
Mr. Wong?
Yeah.
But I understand that when they show this pie chart, when the question says about time, that means it should be 24 hours, right?
Yeah. Correct. Percentage,
Thank you.
A percentage is percentage, Manjula?
Percentage means 100%.
Yeah, very good. If it's a day, you times 24. If it's percentage, you times 100. If it's degree, you times what? Degree.
360.
360 degree, correct. Yes.
Okay,
Yeah.
thank you.
If it's per year, how many days per year? You times what?
Per year is 365 days.
You times 365. Yeah. So it depends on you look at the fraction, you times
What?
according to what they want now.
Oh, the question now. Okay.
Yeah, depend on the question.
Okay.
All right, back to you again, Christine. Is it okay now, Christine?
Oh, okay. But there's another one. On the right
1/3.
says 20.
On the right, 1/3.
The 10-hour.
The 10. How do I get 10 hours? Is it? How do I get 10 hour? Right? Is it the question? How do you get 10 hours?
They are finding for sports, is it?
Oh, okay. Now this one, this one actually is based on the question for question number B. Question B. Okay. Now you look at this question B. Question B, they ask you what is the hour spent on the spot. So what you do is you look at I erase this again first. I erase away first. Okay. You see, you the first one you already calculated the first one. This one is supposed to be, this is 6. This one no problem. This one is 6. I thought this is 6, right? 6. Now you need to calculate what is 1/3. What is 1/3? 1/3. I have shopping. I got 6 hours. Sleeping. I got 1/3 hour. What is 1/3? You need to take 1/3 times how many hours per day? 24, right? Give you what? That's why it give you 8. Am I right? This is 8. Yeah. Is it okay? 8, right?
Yeah.
Now the whole day is 24. They already say that the sports and the revision is equal. So what I need to do is I find the whole thing first. Now the circle itself is 24 hours, isn't it? I just take 24 hours minus the shopping hours. Shopping hours is 6 hours, right? Minus the sleeping hours, which is 8 hours, give you what? Give you 10 hours, isn't it? 10 hours. So this one total is actually 10 hours, total 10 hours. But they always say that the sports and the revision is equal, isn't it? So what do I do? All I need to do, I just take sports, divide by 2, 10 hours, the whole thing, 10 hours divide by 2, I give you a 5, That's the reason. So sports and revision give you 10 hours. Yeah? That's the reason why you need to find 10 hours. You need to find 10 hours now. This is 10 hours. This one is 10 hours. This highlight. Maybe I change the highlight. I change the drawing. This is 10 hours. This is 10 hours. This one 10 hours. The whole thing is 10 hours. Yeah. Whole thing 10 hours. Is that okay? Is that all right?
Oh, so I have to find the 10 hours. Okay.
Yeah.
10.
This one, okay. So 10 hours. So this is 5. 5, right? This is also 5. Why? Because they're equal. Equal. Okay. Frequency. Yeah. Okay. All right. The time is 8:30. I think we better go for a short break. You come back at 8:45. All of you, is that okay? We have stopped. We have done the pie chart already. Right? We have done the horizontal bar chart, pictogram, vertical bar chart, pie chart. Now we're going to do on histogram. Histogram. Okay. Right. You notice histogram is very similar to bar chart. Histogram is very similar to bar chart. And you look at this first histogram. Frequency table and the histogram. Wait, I turn on the aircon a bit lower. Too hot, I get sick. Okay, back to this again. Now this recall the frequency table record obtained from survey or questionnaire. This is the way we do tally, right? When you want to calculate how many number of watches how this frequency actually talks about how many watches number of watches the number of student has and number of student holding one watches 76 students. Number of students having 2 watches, this one is 78 students. Okay, so that's how you do survey lah. This is how you do survey. Okay, then this is what we have, and then okay. You can use a histogram. A histogram can be used to illustrate the information above. Now, a histogram is very similar to a bar chart. That's why I say a histogram and a bar chart are quite similar. Okay, both are using column to represent frequency. Yeah, how many times that means your histogram also look like that. You notice that it looks like a bar chart. Okay, but maybe the only difference is the way they illustrate the diagram lah. So draw a histogram based on the frequency given in 263. So 263, this one, you're supposed to draw a chart, okay? All right. So this one refers to a group. This is just like a group, This one, this is one watches, this is two watches, this is three watches. Now, the histogram, if you look at this, it looks very similar. You can see, this is actually this is like a group. Histogram always it has a group of one watches. This is a group of two watches. This is a group of three watches. Normally, histogram make use of a group, more of a group. Okay. So it can be between one. The first group can be between. I can be represented as a group of data lah. Let's say I can pick 0 to 100 watches. This one could be 100 to 200 watches. This is 200 to 300 watches. This is 300 to 400 watches, and so on. So this one, histogram, normally we use the word histogram when the data below is more of a group. Okay, all right. But you notice similar. You ask me, is it the same as a bar chart? It looks like a bar chart also, right? Okay, all right. Okay. Let's do some diagram, just some example, then probably you can see better. What example 6 demonstrate a histogram using a group data for group data? For group data, instead of labeling the individual column at the bottom middle of the column, we should be labeled them. Okay, look at this, okay? Yeah. Okay. Look at it. This diagram measure the weight of girls. Measure the weight of girls in a school. Those between 40 and 45, you have 390 students. Those between 46 to 50, you have 310. Those between 51 to 55, you have 180. So these are the group. Again, this is a group, right? This is a group, You notice that? Yeah. So if you draw the histogram, draw the histogram to illustrate the data on top. How does it look like? You look at this one? Yeah. Can you see? You look at the first one. Okay. Between 40 and 45. Between 40 and 45. Between 45 and 45. First group. So this is the first group. Between 40 and 45. Notice that? Yeah. Please consider one group. Can you see? Yeah. Between 40 and 45, you have how many is this? Can somebody read to me now?
390.
390. So you must base, if you measure, you must base on 300. This is 310, right? Because every 310, every 2 square is 10. 310, one square, 10, 20, 30, 40, 50, 60, 70, 80, 90, 390. Every square, small square is actually 10, okay, 390. So this one become a group. Like just how the watches, the watches become a group. Now, 0 to 1, you can also consider as one group here now. One group here, one group here, one group. So it's more of a group histogram. So in this case, back to this again. Okay, from 40 to 45, one group. From 45 to 50, another group. Okay, you notice that? Okay. So 40 to 50, for this particular group, how many students holding, how many students between the mass 45 to 50? 210, isn't it? If you read the table, it's 210, yeah? Between 55 and 60, how many? Can somebody tell me? Between 55 and 60.
290.
240, is it?
40, yeah. Okay. Then between 65 and 70. Between 65 and 70.
Between 60 and 65.
Between 65 and 70.
65 and 70 is 110.
The,
110.
sir, about 110, sir.
Yeah.
Between
I think so, sir, because the line here you put
between 50 and 55. 50 and 55.
six,
Between 50 and 55, this one.
so 2, 3, 4,
180.
180.
180, right? Yeah, 180. 180, yeah. So in the exam, it's good that you write down the number. And between 60 and 65 is 150, right? In the exam, it's good to write down the number. Yeah. Okay. So this one consider one group, this one group. Now you want to notice something. What is this? Do you know what is this? Can somebody tell me? What is this? Can somebody tell me? What is this funny thing?
So it's a minus.
No, this is not minus. Now they start from zero. Yeah, sorry.
Say
Again, say again. What
Jump
did you
to
say? Very good. Jump to 40. Yes, jump to 40. Because if you don't, because you see they start from zero. Both also start from zero. Okay. But this one actually every square is 10. We all know it's very accurate one. 10, 10, 10, 10, 10. But this one is different. This is every one square is 1. 1, 1, 41, 42, 43, 44, 45. But if you go backward, this one should supposed to be 35, isn't it? Supposed to be 35, right? Right? But instead of putting it so far away, they start from zero. So this one represents jumping. So because behind 45 behind 40 there's nothing. So I don't want to draw unnecessarily. Start from here. Okay, in other words, I don't want to draw unnecessarily. You start from here now. Very unnecessary, isn't it? So if you can still start at the same spot. But this one, since from 0 to 14 there is nothing, I can actually put jump to 40 by using this particular thing here. By using this drawing. This one means jump, yeah. Means jump. Very good. This means jump, yeah. Jump
So
to
Mr.
40.
Wong, in exam, do we need to write like that?
Up to you. Up to you, yeah. But if you jump, you better write like that. When you're jumping, you better write like that. Manjula, if you if you are jumping, you must write like that. If you are jumping. But if
Z,
yeah, if there's a gap, jump, you better write like that. Yeah. Yes. This is called jumping. Yeah.
Jumping Z. Jumping Z.
It's a jumping Z. Yeah, jumping jet. You know the word jumping jet. This is jumping Z. Yeah. Okay. Hello, a question. Oops. Hold on. Okay. What's the question? Draw the histogram. You already done this, right? Okay. How many girls are there in total? What do you do? How many girls? Actually, just add up here, Am I right? How many girls? Yeah. Find the ratio of the girls between 51 to 55, weighing to the weight between. So you find the weight between this and this. Yeah, this and this. Am I right? Find the ratio of the girls weighing 51 to 55 and 61 to 65. So what do you have? So C will be what? 180 is to
6,
150.
divided by 30, sir.
The ratio is 180 to
150.
6 is to 5, sir. 180 to 150.
Then you reduce to a lower term. So you reduce. You cannot just leave this alone in the exam. Ratio you must reduce it. So become 0, 0. Divide by 3, 6, 7, 3, 8,
6, 5.
5, 6 to 5. Yeah. Okay. That's why I get 6 to 5 in the end. Is that okay? Yeah. Okay. The last one I think is a line graph. This is a line graph. What is a line graph for? line graph. A line graph is a simple line that joins different points given data in the graph. It is useful for representing data that changes over a period of time. Normally, line graph is for time. For time. Normally. Okay, let's do this. You can see this is a line graph, right? You see the time, Monday, Tuesday, Wednesday, Thursday, Friday. Or it could be January, February, March, April, May, June, July. Or it could be a morning, 9 a.m., 10 a.m., 11 a.m., 12 a.m., 12 a.m., 13, 14, 15, 16, and so on. Yeah. So normally line graph is used for timing. It could be year, in the year 2000, 2001, 2002, 2003, 2005, so on. So normally line graph used for time. Let's look at the diagram. One example. Any question first? Any question with histogram first of all before I go on? Anyone histogram? Anyone? No, nobody. Yeah. Okay. Look at the line graph. Yeah. Next one, line graph. Okay. Look at this diagram. I want you to look at this diagram on your own first. Look at the question. I also don't know who attended today. I just downloaded the attendance already. Okay. An office had 200 employees during lunch hour. An office had 200 employees. During lunch hour, some employee order fast food delivery. The line graph shows the number of employees who order fast food from Monday to Saturday. Oh, this is fast food. This is fast food. You understand this diagram? This one shows you the employee ordering fast food. Yeah. Monday, how many people order fast food? Monday.
160.
One what?
60.
160.
Sorry, Mr. Wong, may I screenshot the question?
Yeah.
Okay, thank you.
Are you sure? I don't think so. 1.50. I think so.
Is it?
Is it 250?
Every is 100 and 100 what? 50 less. 160. 260.
It means 5, 10, 15, 20, is it?
170, 180. Every 2 square is 10. Is 10, So this is what? This is it 150, 160, 170, 180,
90.
150, 60, 70. No, I'm wrong. Cannot.
It is 155.
Yeah. 60.
Yes, 5, 10, 15, 20. Stop on.
Yeah, so this is 150, 160, 170, 180, 190. Yeah. So every 2 square.
155.
So this is 155. Yeah, this is 155. Okay, once you establish the first one, the rest are the same. So the second one, Tuesday.
Tuesday is 105.
05. Wednesday?
108.
And
20. Yeah. 20. Then this Thursday, right? Thursday, right? 50, 60, 70, 180 what? 185.
cannot be properly lah.
15, 20.
185, right? Is that correct? 185, right?
50.
Yeah. Friday, right? Friday?
45.
45, 45, yeah.
Friday is.
And this one, the last one, Saturday? 50.
55.
56.
56.
55, 60.
56.
No lah.
No.
No, no, no.
2, 4,
60,
8, 10, 60,
75,
60,
35,
60,
180
18,
180.
Am I correct?
huh? Saturday is 180? No.
Yeah, 50.
It's 50 above, I'm sure.
50.
No lah.
50 above.
Between 50 and 100.
Yeah.
Yes, sir. It could be lesser.
100.
50, 60, 60, right? 70. Correct what? 180 what?
Is it 58? No.
180 lah. 100, no, 80.
80.
80. Am I 80? Am I correct?
80, sir.
80,
You're
right?
right, sir.
Yeah, it's 80 what?
Because
You see, this is 50. This is 50, 50. This is 50. This is 50, 50. 60, 70, 80 what? This is 80. Yeah. That is why I told you in the exam, it's very important you write down the figure on the square. Yeah. Very
Correct.
important. Or else you keep looking, every time you count already, you come back the question and start counting again. Yeah. So write it down on the piece of on that die. Your exam paper you're allowed to write one, no? So you can just write it down, okay? It's okay one, yeah. So okay, now you know your first question. Which day had the least number of employee ordering food? Can you tell me which day?
Friday.
Friday.
Yeah, Friday. How many employees did not order fast food on that day?
Oh, no. It's you take 155 plus
Day.
1, 2.
Huh?
Sunday.
Huh? No. The first question, which maybe I make it lower, then you can see the question. Okay, like that you can see. Which day is the least number of employee order fast food? You know that the answer is on Friday, right? Am I right? Okay. How many employee did not order fast food on that day?
So you take a total minus 45.
Yeah, total minus 45. What is the total? What's the total?
155 plus 105 plus 120 plus 185 plus 80. Then the total minus 45.
No.
200.
No.
200 minus 45.
Yes,
Minus-
200 minus 45. Am I right?
200 minus 45.
Why 200? Oh, 200 employees.
Yeah, it's 200.
Oh, I thought
Yeah.
that. Oh.
Because must take the
I
teachers
forget the question.
number of employees.
You forgot the question.
Yeah, on top also.
It's 200.
Okay, already.
Okay, so now you know 200 minus 45, right?
Yeah, 200 employees.
Yeah.
Never see on top because cannot.
Okay, next question.
Okay.
How many more employee order fast food on Tuesday than on Wednesday? So you compare.
Then on
How
Saturday.
many more employee order fast food on Tuesday
Tuesday.
Tuesday is
compared to Saturday? So what do you do?
Minus?
Minus,
lor, yeah.
105 minus 80.
Huh?
That will be 25, sir.
25.
25, right?
How many price are the fast food?
Is it correct?
Yes. Plus Tuesday and Saturday.
Azima, is it correct, Azima? No. Which question are you talking about? Which question?
More employees.
I didn't quite catch what you just said.
The question, B. Are you talking about B? How many employee order fast food on Tuesday than on Saturday? On Tuesday, how many people order fast food, Hazima?
05.
Look at the graph. Look at the graph, you can tell. How many people order fast food on Tuesday? Yes, Hazima?
On Tuesday,
Yeah.
105.
105. How many order fast food on Saturday?
80.
80. So how many more order on Tuesday than on Saturday? How many more? You just take
You
105.
take the Tuesday.
Take Tuesday minus Saturday, yeah. Am I right? So you have that's how somebody mentioned how many? 15, is it?
25.
25.
25, sir.
Oh, 25, sorry.
Yes, sir.
Yeah.
25.
How many more means it's different? You're just calculating the difference. Yeah. Oh, this one easy. Find the average number of employee order fast food on the 6th day. So what do you do?
On this 6 days.
Average.
Average. How do you cut the average?
Total plus, is it?
200
Plus
Total.
this, plus this, plus this,
plus everything
plus this,
Divided
plus
by
this.
how many?
Divide by?
200.
divide by
Divide by 200.
Cannot be, sir. Because divide by 6.
1, 2,
Divide by
3,
6.
4,
6,
5.
yes.
Divide
Divide by 6, yeah.
6.
Why divide by 6?
115.
Why divide by
Monday there's 6. Monday until Saturday.
Yeah,
Sunday
Oh,
same.
are working.
5 days.
Correct. Monday to Saturday. You're taking the average day, isn't it? You're
Yes.
taking the
6
average
days,
day, right? Yeah,
Is it
6
6
days.
days, Mr. Wong?
Yeah, 6 days.
Oh,
6
okay.
days. Monday to Saturday. Yeah,
Yeah.
6 days.
These days.
So this is line graph. Interesting, line graph.
Very.
Okay, very interesting. Hey, no more already there. Hey, let's look at the question. I finished already, I got no more already there. Let's look at the question. I close this, I close this. I look at the question. Look at where is my this one I told you this one is the easiest. This chapter is very easy. Do you agree with me?
Mr. Wong,
Yeah, Darwin?
when you say question, are you talking about
Yeah.
the 207 page 270, that one?
I'm talking about exercise 9 lah. Exercise 9. Let this one. This one. This is the
Because
question.
this chapter got the most pages out of the whole 1 to 8, that one.
Really? You mean the question?
No, I mean, I printed chapter 1 to 9. This is the most paper I have, right?
Oh, really? Are you sure? Oh, maybe I think it's a big tick lah. Because the graph is big, because there's a lot of graph. That's why it's a big tick. You know what I mean? And this is the one I'm referring to actually. Yeah. Okay, let's do this. Let's do together. Look at this question, please, everybody. This one no answer one. You must do it yourself. As part of the recycling project, the number of empty drink can be collected by each student is tabulated. So this is okay. Can you tell me what kind of diagram is this? Pictogram, And the answer is there in fact. Yeah. Excuse me. You know the aircon is very cold. Sorry, wait there.
You mute.
No, I mute because I want you all to look at the question yourself first before I talk.
Oh, okay.
Also, I sneeze. Don't hear my sneezing. Okay, let's look at this. As part of the site recycling project, the number of empty drinks collected by each student tabulated. Study this pictogram carefully and answer the question, all right? Write down, I told you write down, right? Always write down on that exam paper. So one tin represent how many?
10.
10 empty drink.
10.
Right on the right of the diagram, 1, 2, 3, 4, 5, 6, 7, 8. Write down, okay? Always write down. You must write down on your exam paper, or else you will forget. Okay, you don't keep counting. You're wasting your time. This is 30. Then some 80, 90, 100, 110, 130. Isn't it?
Now it's 130.
40, 50, 60, 70, 80. 80.
110.
110. 110. Okay, always write down. I always told you, right? Always write down. Next. How many more empty drink can the Russell collect from Jeremy? So you compare Russell and Jeremy.
Minus.
You minus us?
Yeah.
Right. So this
80
one,
minus 30.
this minus this, yeah?
50.
So is what is the total number of empty drink collected?
Plus everything.
430.
Plus all together. Very good.
430.
Question. Oh, finish already. Easy lah. These are easy. Number 2. Yeah. Okay, right now, 120. Each loaf 120. 1, 2, 3, 4, 5, 6, 7, 8. 8 times 12. 960. Am I right?
Mm-hmm.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
40.
12 times 1200, 13 times 12. Somebody give me an answer, please.
30 the 120. Mr. Wong.
Huh?
120. Represent 120. Each is 120.
156, 13 times 12, right?
Yeah, 13 times 12. How many?
156, sir.
156. Thank you.
Welcome, sir.
This one and the next one. 1, 2, 3, 4, 5, 6, 7, 7 times 12, 84, right?
84.
84.
Mr. Wong, it's not
Huh?
12, it's 120 loaves of bread each.
It's 100.
120, yeah. Oh,
Yeah.
yeah.
Each
Where,
bread represents
each
120.
bread 156 there. Yeah. So this one make 156 so little.
Yes, sir. 1, 2, 3, 4, 5, 6.
13 times 120. Sorry, how many again?
Oh, sorry, sir. 13.
560.
Yeah, correct.
Slowly. Li-Ling.
1560.
1, sorry, 1, 5, 6, 0. Yeah, how can it be so little? That's why. so quite strange. Okay, next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 1002, right?
1002.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8. 8 times 12, also 96.
960.
That's why you must always write down. I keep telling you during the exam, you all must write down, right? Always write down. Always. Name 2 bakeries sold the same number of loaf. Okay, name me the 2 bakery. Answer?
Sir, first one and the last one, sir.
Yeah. So which is Everfresh and
Everfresh Bakery and
Mr. Allison, right?
Mrs.
Allison
Bakery.
Bake. Mrs.
Yeah.
Allison is my principal name.
What was the total number of leaf of bread? Okay. What was the total number of leaf of bread sold? Oh, loaf lah, leaf. Loaf. L-O lah, loaf lah. L-O-A-V-S. What was the total number of loaves of bread sold? Yeah.
Must add all, sir.
So what's the answer? The total number of loaf of bread. This is loaf of bread, not leaf of bread. What is that? Can you see? Wrong,
Leaves of bread.
5520.
wrong spelling. 5.
20.
Add up together, right? Plus this, plus this, plus this, plus this, plus this, give you 5520. Am I right? Lily? 5520. Is it correct?
Yeah.
Okay, thank you. Number 3. You see, pictogram very easy, right? You all agree or not?
Okay lah.
Pictogram very easy, Okay lah. Okay, this is here you do for me this one. You do for me. What is the first thing you do first? Tell me.
Write the number of the air dryer.
Yes.
At the side.
Write down. Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is
880.
This is plus 88. This one 11.
968.
968. This one? Stacy? 1, 2, 3. Huh?
704.
7. You times 88, right?
Yeah, 8 times.
3 times 88.
264.
Last one?
Last one is
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 times 88.
1408.
1408.
1408.
08.
08.
Okay. Now, 5 customers compare the amount they spend in a hairdresser salon in the past 1 year, okay? Their reply are represented in the pictogram below. Okay, this is 1 year. They go to the hair salon. Okay, who spent the least? Who spent the least?
Winifred.
How much you spent?
264.
264.
Okay, 264. Very clear. Find out how much more Jasmine spent than Jasmine and Stacy. So what do you do?
How much Jasmine
Minus,
spent? Jasmine
minus.
minus the Stacy.
Just minus. Straightforward, right? Okay,
AC.
this one too easy lah. Don't want to do this already lah. Too easy.
Sorry,
Can we do
Mr.
another one?
Wong.
04.
Yeah.
Please slow
Yes?
down. I'm
Oh,
still
okay.
at that question.
This
I'm
one is
still
it?
figuring out. Yes.
Which one? Which one are you
I
figuring? Tell me.
still the the second one.
This one,
B.
the second one. Actually, second one very easy. Yeah, both both. You're talking about this question, is it? Christine, is it? Are you referring to this question?
Yes.
Okay,
Yes.
find out how much more Jasmine. What does it mean? Find out how much more Jasmine spent than Stacy. What does it mean?
We want to know how many more, how much
Yeah,
more.
how much more? So when you want to find how much more, you just have to minus only. You just take this one, 1408, which is Jasmine, right? Stacy spent how much? Stacy spent 704, right? So minus 704. That's the answer.
Sorry, I think I forgot how you calculate to get all the 880, 960.
This one very
I
easy.
forgot already.
Okay, how do you do this? You're wondering how I get this, is it?
Yeah.
Oh, very
Which one?
easy.
Where?
You see, one hair dryer represent how much? 88. All you need to do is just count how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 10 times 88, give it 880 lah. 10 times 88. So you give me the second one, Christine. How do I get 958? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So I take 11 times
88
Very good. Next one. 1, 2, 3, 4, 5, 6, 7, 8. How do I get this?
times 88.
Yeah, now you know. Okay. This one, 3 times
3 times
1. 3 times 88. Yeah, correct. And this one is, of course, quite a lot lah. 13, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 times. This one is 16 times 88. Yeah. Now you know how I get it already? Yeah.
Yes. Yes,
Yeah.
Mr. Wong.
Is it okay? Any other question, Christine?
No, I'm just copying everything.
Oh, okay.
Yes.
Quite straightforward lah. Oh, sorry.
Yes.
Sorry. Quite straightforward. I didn't know you missed this one. I didn't know. Yeah. Any other question? Anyone? Darwin, any question, Darwin, from you? Darwin?
Yes, Mr. Wong.
And any question from you? Any question?
Actually, I don't know. Maybe the question I'll try tomorrow. There were all these questions. I haven't finished this one yet.
Oh, okay.
Actually, I'm just copying this one first because it's going so fast. Yeah.
I'm going. I'm so sorry. I didn't know so fast.
So can you see question B?
Question B, B.
B, yeah.
Is it?
Yes.
Yeah.
Okay.
Okay.
Mr. Wong?
Yep, Darwin.
The below one for Jasmine, how do you get 26?
How do I get 26? Where?
26 times 88, that one.
Sorry, where is it? Oh, this one. Because this one is 26 hair dryer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Not 28, it's 16, 16. 16 times 88, 16.
Oh, then I see wrongly.
It's actually 16, yeah. Look at 28, yeah, so sorry. It's 16. Mm. Is that all right? All of you? Oh, okay. Can I move on? Those another pictorial diagram. Okay, very easy. Yeah, like the number of babies delivered in the 5 years. This one is the number of babies born. Born. Okay, 5 years. One baby bottle represent how many? Wow, wow, these are a lot. One baby.
1,800.
1,800 and 1,800. 1,800. Okay, now you tell me how many. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wow, this one I don't know whether I should write down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 times. My goodness.
It's
So it's
34,200.
200.
Yeah, this one a lot.
1,200.
Can I see what the question first?
Which has the least babies?
Yeah, no choice. Okay. Okay, this one, let's hope that they don't ask you. Wow, they ask you. Again, what's the number?
The second one is 24, sir.
Okay, can I have one person give me the answer now? Can we have Jeffrey, can you give me the answer?
What answer?
2012, can you tell me how many babies are there?
19,008, is it?
Yeah.
34200.
34200. 34200. Okay, the next one, Lina, are you there now, Lina? Lina. Hello, Lina. Aisha. Aisha, are you there, Aisha? Hello, Aisha. Diana. Haja. Hey, where are you all?
Yes.
Okay, Diana, can you tell me what is 2011, Diana? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this is what? 24 times 1800.
800.
Yeah. What's the answer? Diana? Read to me the number instead.
43200.
43200. 43,000, is it?
Yes.
43200. Okay. Haja, are you there, Haja? Haja, are you there, Haja? Oh. Okay, Liling, 2010, Liling.
2010
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 times 1800. Alina? Yeah.
They want 32400.
Slowly.
32400.
32400. Okay. Hazima, can you give me the 2009, please, Hazima? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Hazima. 20 times 1800.
36000.
36123, right? Yeah.
Yeah, 36000.
Okay, last one. Yeah, Hawani, are you there? Hawani? Haswani. Yoo-hoo, Aswani, are you there? Aswani. Hajar, are you there now? Hajar, can you give me answer now, Hajar? Javen, are you there? Javen? Javen. Christine, give me this one, Christine.
Yeah. Can I answer the last?
Okay, answer, give me the, which one? 2009,
No, is 60 times 0.800 is answer 28800.
Which one? 2010, is it?
2008.
2008, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? 16
Yes.
times 1800. Answer, please.
28800.
28800.
Yeah.
Now we can do already. Okay, now we first question. Which year has the least baby delivered? Which year? Now this one is inside. You just look at the one that with the
2008.
least bottle, right? Least baby bottle, isn't it? You look at the least baby bottle is 2008. Yeah. 2008. And which year has the most? This is
2011.
this year has the least is 2008. Which year has the most? The most is 2011. Now you look at the bottle, you know already. The most on 2011, isn't it?
Yeah.
Okay, give me the difference.
14,400.
How do you do that? Can you tell me how you do that?
First, take the most babies and the least babies minus.
Okay, take the most baby. What's the most baby?
43,200.
43,200. What is the least baby?
28,800.
28,800. What is our answer?
14,400.
14,400. Okay. All right. How many babies are delivered between 2009 to 2011? So between this and this, right?
Minus.
All right. So you just had to do what?
Minus.
Where got minus?
Plus.
Plus.
Between
Plus. Yeah.
between.
So you take this one plus this one plus this one. Am I right?
139,800.
29, 10, 11.
Siva, answer Siva.
139,800, sir.
139,800, is it?
Hmm.
Is it correct?
Because I take the total minus the last.
You take the total what?
No, sir. I already added last time.
Oh,
Sir.
I see. But it's the same, you get the same answer. Yeah.
That is
Not difficult, This one,
2009 to 11.
Okay. Question first, before I move on to the next one.
Last one.
Christine, question, Christine.
No question.
Sure, no question.
Just catching up.
Is it okay? Does it look alright to you all?
Yeah.
Too fast.
Okay, too fast.
What is the answer for number B?
Answer B is 139,800. Am I right?
They add together 2009 to 11. 9, 10,
Yeah,
11.
yeah. Correct. Is it correct? Manjula, is it correct? Can you check?
Wait, let me.
Is it correct, Manjula?
I'm calculating. It's 111,600.
Can somebody check, please?
Yeah, my answer also same.
So this is wrong, eh?
111,600.
This is wrong, Mr. Siva.
208. Never mind, sir.
Okay, Manjula, answer again, Manjula.
Sorry.
111,600.
111,600. 111,111,
Yeah, 111,600.
Okay.
So how do you calculate
Which one?
between 2009 and 2011?
Okay, because they ask you how many, They ask you how many. So what do? All you need to do, just add this one, add this one, okay? Plus this one, plus this one. 3 together.
Or 3?
Yeah, because it's between these three years, what? You just add the number of babies born on that year. That is why I told you all must write down the total number. Every chart you must write down the total. They sure ask you one, how many this, how many that, how many less, how many different. Then the figure there, all you need to do is just have to minus or plus only. That's all. Yeah, you all must add it down on the chart. Yeah. Is it okay now, Christine? That's how we did lah.
Yes, yes.
Yeah. Okay, can we do the last question? Can we do the last question? Can we call it night already? Wow, you all got a lot of things to do. What is this? Oh, newspaper. Yeah, newspaper. The amount of old newspaper collected by various recycling company are tabulated. Okay, wow, 2,500 kg leh. My goodness. Okay, first one. Jeffrey. One.
6.
How come cannot draw? 1, 2, 3, 4, 5, 6. 6 times 2005. You see, Jeffrey?
15,000.
15,000. 15,000
Yeah.
Okay. Haja, are you there now, Haja? Diana? Anyone? Diana, are you there? Okay. Hazima, please, second one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Answer? 14 times 2500. Wow, goodness. Hazima.
35,000.
35,000.
Yes.
35,000, okay. Aswani, C, please. Aswani. 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2005. Aswani.
20,000.
20,000. 20,000. 1, 2, 1, 2, 3. Okay. Charmaine, are you there, Charmaine? Charmaine, give me 3, please, Charmaine. 3 times 2005. Charmaine, are you there? No? Charmaine?
7,500.
Sorry?
7,500.
Yeah, 7,500. And the last one, Siva, can you give me the last one, please, Siva? 3.
So,
27.
11.
Wait, 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, right?
Yeah.
11 times 2005. Siva?
27,500.
27,500.
Yes, sir.
Okay, now we are ready for the question already. Find the difference in the amount of newspaper collected between the company with the most collection and the company with the least. Okay, now this question asks you, you find the most and the least, what is the difference between them? So all you need to do is just to minus, isn't it? The most is actually this one. Do you agree or not? The most.
Yes.
D, right? Which is the least?
D.
Complete D.
D, right? D, right? D. Okay, all you need to do is just take 35,000 minus 7,005. I will take, am I right? I will take 35,000 minus 7,005. What's your answer, please, Manjula?
27,500.
27,500. 27,500. Is this a correct answer? Everybody check, please.
Yes.
Okay, the second one. Find the total. Wow, this one. What do you do? Find the total number of old newspapers. You just
All
add
the plus.
plus this one, plus this one, plus this one, plus D, plus E. You have the total already, isn't it? Okay.
Yeah.
Can okay, let me ask somebody to give me Darwin, can you give to me Darwin, Mr. Darwin?
Give you what?
Give me the total of A B C D E F. A B C D E.
All of them, right?
Yeah, all of them.
Okay, sure.
And can you give me an answer now, please? What's the answer, Darwin?
Wait, I'm still calculating.
Okay. Wait. Be patient, everybody.
95,000?
Is it 95? 95.
95,000.
Can somebody confirm?
Now,
105, sir.
No.
100,000.
Wow. Okay. Another one. Somebody.
105,000.
105. Oh, it's 105. Maybe it missed a number somewhere. It's 105,000. 1, 2, 3. So that's the answer. Yeah. Okay. What y'all need y'all to do? Go. Number 6 also quite easy. I'm very sure you can do. Now I want y'all to do the tougher one. The tougher one are actually all these. All these are the tougher one. Especially the pie. I got pie now. Pie very tough. I noticed the pie question. Any pie. Especially these. Please. Y'all at least try to do this. Okay. 16. Try to do this. 16. 17. 16, 17. Okay, these are the difficult ones. 16, 17, got 18 or not? 13, 16, 17, 18. Or y'all must do on your own, okay? Then we check the answer next week.
Okay.
19.